In tonight's homework, students are going to work on thinking about a meter broken into its tenths and also its hundredths. So students are going to be thinking about the values when they see them like they do in problem 1, thinking about how many make the whole. So how many parts has the meter been cut into? So if students look at it, they see that it's broken into tenths. The question for A says, how many parts are shaded? So that would become the numerator. And then it says, what fraction of the meter is 3 centimeters? So students should remember that the centimeters were these smaller parts. And the centimeters, we know there's 100 centimeters in the meter. And so they want to represent 3 of those, and that would be the numerator. For part C, it's asking in fraction form to express the length of the shaded portion. So you'll notice these two portions are the same. So each of these tenths up here has been turned into 10 hundredths. So this first part is 10 hundredths, then there's 10 more hundredths, and then there's 10 more hundredths. My lines aren't exactly accurate, but students should see that they're adding those up or thinking about what's equivalent to 3 tenths, how many hundredths. That's going to help them solve C. Then they're going to find that same portion and put it in a decimal form. So students should remember that the decimal is here. This is the ones place, this is the tenths place, and this is the hundredths place. And then they should be able to answer E based on what they did right here. On the next part, what students are going to do is fill in the equivalents. So students may feel more comfortable finding equivalents to these. So they should write each as probably a fraction to see it. So when I see this number, I see 5 tenths. And I want to ask myself, how many hundredths is that equal to? This is the part I'm missing. So students may recognize to make equivalent fractions, they have to multiply both the numerator and denominator by the same number, solving based on the denominator. So 10 times what gave them 100? They should know that's 10. So to figure out this missing numerator, they need to do the same thing. What we did there is shown here. And then students can use the same strategy to solve there. They're noticing that it should be getting 10 times bigger. For part 3, it says use the model to add the shaded parts as shown. So if you look at the first part, we have this broken into tenths. I'm going to kind of show you this a little bit closer. You see these 10 sections here. These are tenths. And so each of those is worth 1 tenth. What they've done here is they've started to show the centimeters. So what they're showing here is they broke that 1 tenth into its equivalent, which is 10 hundredths. So they made 10 smaller lines, and if they broke this whole meter into those small lines, there would be 100 of them. And then there's 10 that are shaded here. But these amounts are equivalent. We didn't change the value, we just changed the size. So what students see here is they have 1 tenth plus 3 hundredths, and they get 13 hundredths. Some students may be confused because they say tenths and hundredths can't be added, but thinking about what's the equivalent here. 1 tenth is the same as 10 hundredths. So now they can see 100th plus 100th, and they see 10 plus 3 is 13. That may be a little bit easier. The reason that they leave it in this form is because this form right here aligns to the place value. You see 1 in the tenths place, 3 in the hundredths place, so we see that as the number bond. For part B, students are going to do the same thing. So they can count these up as tenths. So they have 1 tenth plus 1 tenth plus 1 tenth. And then counting up how many hundredths they have here. They have 8 hundredths. So this is the number sentence, and then what students may want to do is they may want to put in the numbers in the place value. So how many tenths goes here in the tenths place, and then how many hundredths goes here in the hundredths place. So they should get 3 tenths, because I see the values 1, 2, 3, and then 8 hundredths, or 38 hundredths. Students should be able to solve C by themselves. And then this is where they're going to do some work of shading. So 9/10, remember these are already broken into tenths. So they would shade the number they see. When it starts talking about hundreds, they need to think about if each of these were broken into hundreds then. So here there'd be 10 hundreds, 10 more hundreds. Seeing this value going from 1/10 to its equal value of 10 hundredths. So for here, for 15, they would shade 1/10, or they could say that's 1/10. And then to get the 5/5, they're going to have to try really hard to draw those small sections. I think that's 10, and shading in then 5 of them, about half. So it may be a little challenging for the students to draw the tenths, but they should be able to do it. And then for 5, remember the number bonds are connected to the place value. So for students, they may want to first write the equivalent decimal and then make the number bond. So for instance, I'll start on B. They see it saying the name helps too, 38 hundredths. So they're going to hear the name, 38 hundredths. And then they can easily see the number bond. There's a 3 in the tenths place, plus 8 in the hundredths place. And that's how the number bond looks.